Graphene is a unique nanoscale form of carbon that is disrupting legacy materials, bringing step-change improvements in performance across a wide range of industrial and consumer applications. From energy storage and electronics to everyday materials, graphene enables products that are better, stronger, and lighter, while increasing durability and improving sustainability. Graphene is leading the era of new advanced materials.
The following is a presentation that was given as part of a two-day virtual Graphene Investors Conference, hosted by the Graphene Council.
Thanks a lot, Terence. Good morning, everyone. Thanks for having me. My name is Rudy Beeri. I'm the founder and CEO of StatPeel, and we are a manufacturer of analytical instruments. Next slide. We're a Swiss-American company. We're located on both continents in the mountains, here in central Switzerland and in the US out west in Utah. Next slide, please. This is the valley I grew up in. We started the company back there. So we're about 1 hour south of Zurich. If you go over the mountains, there is Davos. Probably if you've heard about the place. We developed the tool. A few years later, we moved to this industrial compound down here. It's called Eternit. Next slide, please. This is a manufacturer of cement products, and over 90 years, they used huge amounts of asbestos. Everyone knows what asbestos does, and growing up around here, I've seen the implication firsthand. Next slide, please. I spent then some time in the semiconductor industry, and I saw that new advanced materials are appearing on the market. And first, the carbon nanotubes, again, a fibrous material. And I thought, okay, this is an interesting topic to see how can we build a detection instrument to monitor exposure to such harmful materials. And that's what we set out to do. And exactly when you look at the material, it's all carbon. It's a black stuff. And as you know, carbon can come in all kinds of forms and shapes. So as a tube or as a 2D material like the graphene, you're familiar with 3D structures, or even as a ball, a buckyball. Next one, please. And to give you a more detailed view, you see here SEM pictures of those minute particles. On the left, the CNTs, the webs of fibers. In the middle, a couple layered graphene. And then on the right, the typical material that is used in many, many industrial products, carbon black, a nice round arrangement of carbon atoms used by the hundreds of thousands of tons. In general, you don't really want to inhale those particles. In general, you don't want to inhale anything that is not healthy, and specifically not stuff that tends to be biopersistent. And so next slide, please. And because the reason is that stuff can really travel down far down into the lungs, all the way into the alveoli. It can get stuck there in the tissue or penetrate the tissue and go directly into the bloodstream. And then you end up with pictures like this from an NIOSH publication, which you don't want to see as like a carbon nanotube stuck in a lung tissue. And that's what we want to avoid. Course. Next slide, please. And that's also why the regulators, they're pretty nervous about this, and that's why they put very low exposure limits for such materials in place. So in the US, NIOSH proposed or issued a recommended exposure limit of 1 microgram meter cube. For graphene, I haven't seen anything. People are talking about different limits from 1 microgram. I've heard 10, 500. And some people in the industry revert back to the levels for carbon black and graphite. But I can tell you those levels, that's such a high concentration, that's basically standing in a black cloud, which I do certainly not recommend to do. Next slide, please. What does it mean to have such a low exposure limit? To show you that, imagine you have an espresso, you usually get it with a little package of sugar, 4 grams usually. And if you then, next slide, if you go and look at the Empire State Building, the volume of the building itself is about 1 million meter cube of air. If you take your sugar, you grind it up very nicely to a nano-sized powder. Next slide, please. and you distribute it in that building, you end up with a concentration of 4 microgram meter cube. So that means you're already 4 times above the recommended exposure limit. Now that gives you an idea how difficult it is or how tricky it is to comply with those requirements. And also you have to make sure if you manufacture a measurement instrument that you can really go substantially below that. And that's what we did with our instrument. We can go orders of magnitude below. And so for a single wall carbon nanotube, a fraction of those limits. Why is this relevant? Because if you produce such materials, if you handle such materials, you always have a certain release. And you also have always a certain amount of particles present, which most of the time are completely harmless. And you need to know what's the amount of the dangerous particles among the background, among the harmless background contamination. Next slide, please. And that's what we did. We developed a tool for the health and safety purposes that can be worn personal, so you can do personal exposure monitoring. The second point is we said the inspection has to happen fast, and that means the tool has to be on site, so you can take actions if something is off. And the third thing is obviously that it's material selective, that you can really trace and track the material you're interested in. And among to solve those 3 points, we designed and developed and built the tool. Next slide, please. And this is centered around one technology. We use Raman spectroscopy to quantify the material. Most people use Raman for a qualitative analysis, but we took it one step further, and to make this reliable and fully automatic, we designed a completely integrated system. And to do this, we started with a special filtration slide, which contains a nanoporous filter. You can see this on the left. The particles are sucked in, they deposit on that filter, and then we use our benchtop reader to inspect all the collected particles. Then the software goes and detects and quantifies the material you're interested in. Next slide, please. That's how the system looks like. On the left, this is this filtration slide I just mentioned before. Every slide has a QR code. It's a consumable. In some countries, you need to store them for 10 years. They contain those nanoporous filters. In the middle, this is the filtration badge. It's about the size of a cell phone, a little bit thicker. It contains air pumps, silent air pumps, different sensors. It's also the same weight as a cell phone, so you can wear it in a facility, in a lab, even in an office. And then on the right, you can see the benchtop reader, which is a fully automated solution to inspect the filters. It stores the filters, it inspects the filters, it calculates the exposure. It does everything fully automatically. Next slide, please. We were able to get patents for the system in all the major markets. Patents are one thing. The more important thing is validation documents and government customers. And this you can see on the next slide. So we started a couple of years back. We did the validation for Russia. There's one big manufacturer of carbon nanotubes. These days, this is not a market for us anymore. We've done a lot of work in the US. We submitted the documents to EPA. NIOSH owns one of our tools here in Switzerland. The SUVA, the Swiss OSHA, has one to monitor exposure in workplaces. Next slide, please. So I talked about aerosol monitoring. So in the environmental health and safety topic, so that's the health and safety part we've covered. But even if you have a nice, clean factory, you also have a certain release of liquids, usually processed water or wastewater. And it's also, those materials can be a high level of concern of being released into the wastewater stream. And so, because we can monitor materials selectively, so we also developed a solution to solve this. And you can see this on the next slide. This, instead of an air sampler, this is a liquid filtration setup where you have your particles in water, for example. It's then pumped through, again, this filtration slide. And you take that and you see, because we use the same analytical process, the same reader, the limit of detection, limit of quantifications are, again, very, very low in the ppb to ppt range. so that you can comply with any evolving requirements out there in the future. Next slide, please. That's how it looks like. And because we have a solution for liquid filtration, we can also offer this for quality control purposes. And this is really helpful if you manufacture material, if you add material to a product, that you don't have to have a PhD sitting at a Raman microscope all day long and looking at samples. You can automate that task. So you can load the system with up to 90 filters, and then let it run through the night, over the weekend, whatever, to inspect all those samples, and then later on access the database to see what kind of material, what the quantifications are, were detected on those filters. Next slide. To offer customers a way to try out our tool and our solution, we created a little sampling business. It's a suitcase which contains some of those air samplers, filters, a badge, a tablet. We send those kits out. The customer can monitor their environment individually and by themselves. They then return the slides, the filters to our lab for inspection together with the badge sensor data, and we provide them with a measurement report. And that's usually the first step how we get involved with a customer. Thank you. Next slide. Because Raman spectroscopy is a very versatile spectroscopy technique, so we can apply our solution to different markets. So I talked about the advanced materials, but it also works for construction and mining. Usually there people are interested in respirable crystalline silica. Big topic at the moment is the battery industry, all kinds of toxic materials there. Pigments and chemicals, that's usually titanium dioxide, zinc oxide, such materials. It also works for pharma applications, for the active pharmaceutical ingredient to keep them apart from the excipients. Also, growing concern, and especially in the US, a big topic out west is plastics monitoring in water. So there we can monitor the nano and microplastics filtered out of a liquid sample. Next slide, please. How does this work in a value chain? So we follow the complete value chain from the person that produces the advanced materials, then to the person, usually like they can be a functionalizer, they can be a company that turns it into a coating, puts it onto a foil, then someone that turns those foils into a battery, a cell, closes it up. That's where we're involved. And at the end of the life cycle, again, when the cell is shredded in the recycling process, then again, that's where we get involved. And we can cover the regulated sphere. So this is the air contamination, so the exposure, the health and safety topic, wastewater topic, but then also quality control along the value chain. Next slide, please. And because it's a global industry, we have to follow our customers. This is great, right? So this starts maybe in one end of the world and goes around the globe. So I listed a couple of customers we've engaged in over the last few years. Thank you. Next slide. And to summarize it, we can offer instruments for the regulated market, for health and safety, environmental monitoring. We can offer instruments for the quality control topic, but then also having a measurement service business just to provide information for the curious or for young companies that start up. Those are our three revenue streams. And we're looking for investors to penetrate the market further, to scale our business, to invest in our operations, and to grow the company. Thank you very much. And yes, please reach out to me if you have any questions. I'd be happy to answer anything you might want to know. Thank you.
Rudy, thank you very much.
For more information on market opportunities and to connect with experts, contact the Graphene Council at thegaphenecouncil.org.